So in short, a couple takeaways thus far. So we implemented the capability of implementing our own functions. And syntactically, it's really no different from using main, using get, int, and the like. But we did see one gotcha, whereby if you use a function you wrote, and that function's written at the bottom or just elsewhere in your file, you do have to declare it, so to speak, at the very top. And the jargon there is you give it a function prototype. You declare it at the very top of your file, ending it with a semicolon. So then we looked at, again, this issue of scope. And the issue of scope refers to where variables can be used and cannot be used. And if you declare a variable inside of a function, pass it to another function, that function gets a copy of it. And you can't access the other guy's copy back and forth. And that is because of this little picture that we started to draw here, where your memory is given, your program is given different slivers for every individual function. Now, if you take this to the extreme and call some function an infinite number of times, eventually you're going to hit some kind of ceiling. And that ceiling, among other things, has your own program in it, your own program's zeros and ones that were the result of GCC compiling them. And what eventually happens is usually something like this. Odds are this won't really happen to you this week unless you're doing the hacker edition of PSET 1, but this will happen to everyone in this room over the next couple of weeks. Segmentation fault simply refers to the fact that you started in some segment at the bottom of your memory and you overstepped the bounds of someone else's segment, some other important chunk of memory. So this is actually a good thing in that the computer's trying to prevent bad things from happening. But as we'll see, we can actually, with finer grain control, take advantage of a computer's memory. And again, to be clear, the context here might be malicious behavior, not just compromising a server, but frankly, a common pastime on the internet is to create cracks for programs, whereby when you want to install Microsoft Word or Photoshop or something like that, you're usually prompted for your registration code or product code, something like that, that in theory only you have. Well, how are those things implemented? If you double click on Photoshop for the first time, there's probably just an if condition in there that says if not yet registered, show prompt, else show program. Right? So conceptually, it's probably as simple as that. So what do bad guys do? Well, they try to figure out where in the program, where among those zeros and ones there is that condition to try to circumvent it or try to overwrite it with code of their own. So again, this all relates to the capability in most programs to take advantage of or even break their use of memory or even their use of disk space. And it's all because you can address every single byte by way of its number. Byte 0, byte 1, byte 4 billion if you have 4 gigabytes of RAM or 4 gigabytes of disk space. So let's now explode something we've been simplifying in the CS50 library. A string, again, is what in English? So it's text. It's a word. It's a sentence. Maybe it's a single character. It's 0 or more characters in a row. And this is actually the case in memory, too. If I wrote that program a week ago called Hello World, and I typed in HELLO and hit Enter, and that HELLO was stored inside of RAM, those characters would be stored back to back to back to back, one ASCII character, one byte, after the other. And in fact, what really happens inside of a computer program is if I type in HELLO, here's a formerly blank chunk of memory. So this is the first few bytes of, say, 4 gigabytes worth of memory. When I type in HELLO and store it in a string, what really happens is this, HELLO. And then the next word I type in, if it's hello world, might be WORLD. But this is a bit broken, and it's a bit of a lie, because you need some way of distinguishing boundaries between words. So what C actually does is, even though when you type words at your keyboard and they're stored in these variables called strings, even though it does store the word one character after the other, it also puts a special, let's call it sentinel value at the very end. And I'm going to denote this with \0. So we've seen \n, and the backslash almost always denotes something special. It's an escape character. \0 is the way of representing a byte whose 8 bits are all zeros. This is a special character. This is in contrast, just to be clear. If I wrote just 0, that's actually the ASCII character, the text that looks like the number we know as 0, but the letter 0, the ASCII character 0, is not 0000000 in terms of bits. So \0 means a byte's worth of all bits. a byte's worth of all zeros. And I need this one other place, \0, so that now if I have an exclamation point at the end of my sentence, I might have another exclamation point there. So if I typed in hello and hit enter, this ends up in memory followed by this \0. If I then on another line type in hello world, it ends up in memory in the same way. If I type them both together with just a spacebar character, you do not get a \0 after every word. You only get a \0 after every string. So the moment when you use the CS50 library and use getString and hit enter, the \0 ends up at the very end of the string. You might still have spacebar characters in the middle there. So what's the application here? So it turns out that a string in C is just a new data structure called an array. And you might recall from the tail end of Scratch, or specifically the Fruitcraft RPG game, where the little guy walked around stage and he actually picked up like oranges and apples and pears, those kinds of things. He was putting them into a list, so to speak, and to use Scratch's terminology. Well, that's really just an array. An array is a data structure. It's like a special variable that doesn't just store one thing. It can store two things, or three things, or four things all together. This is great for strings because what's a string? It's 0 or 1 or 2 characters all together. So the way in which C implements strings is it takes a chunk of memory, puts the first character here, then here, then here, then here, and at the very end of the string it puts \0. And so what the implication here is that even if you have a string that's been passed in by the user at the keyboard, you can actually get at individual characters in it because they are all back to back to back in this way. So let me go ahead and open this program called argv1. And we can finally reveal what that special thing called argv has been that you might have seen in textbooks or any of the online references. So thus far, all of our programs have been declared with the very simple void. But the question was asked, I think, on Monday, what does it mean if you actually have something other than void inside of parentheses? What if you want a program to take command line arguments? Well, what's a command line argument? Well, most of the programs we've been using down here in the terminal window take command line arguments. There's a program called make, but anytime you type something like beer4 at the prompt, you are passing to make a command line argument, which is similar in spirit to calling getString and asking the user for a string. But notice the one key conceptual difference. A command line argument is input, is a word that the user types before he or she actually runs the program. So it's passed to the program as at the so-called command line. So how does make, how does GCC, how do any of the programs we've been taking for granted in the appliance actually access those? Well, now we can change what main looks like. This is the other correct declaration of main. And it's a little scarier looking, but we'll tease this apart in just a second. Int is the same. Main is the same. What do you think argc and argv might represent? So arg denotes arguments. So just as another function like swap or increment or any of these functions we've been playing with today, or chorus, just as they can take arguments, it turns out main can as well. Thus far, none of the programs we've had to write take arguments at the command line. We hit enter, then we're prompted for a string via the use. We then prompt the user for a string. But if you actually want to take the argument at the very command line, you can declare main as this: int argc, which stands for argument count. And then you can declare this: char star argv, open bracket, close bracket. So this will make sense in just a moment. Let me actually simplify this for a moment and rewrite this as this, which is, again, sort of CS50 style. Not quite correct, so we'll fix it in a moment. This means that argc is a number, and it's argument count. How many words did the user type at the prompt? Argv is what's called argument vector, which is usually synonymous with array. So it's a list. It's a collection of words that the user typed. So when you type in multiple words at the prompt, where do they end up? They end up in a variable called argv. And the square brackets is just C's way of saying this is an array of arguments. That is, this is multiple words, multiple inputs, all inside of one variable, like a Scratch list. I'm going to leave this as string for just a moment, and let's actually see what this program does. I'm going to go ahead and go down here, and I'm going to compile in lectures to source. I'm going to compile argv1, enter, and now notice unknown type string. How do I fix this? Yep, include cs50.h. So now let me go back to my prompt and rerun arg. OK, that's good. Now I'm going to run it, argv1. foo bar, enter. Interesting. It looks like this program simply does what? Prints out what you typed, but one word per line. And then it's got some, just for aesthetics, just some blank space at the top and blank space on the bottom. But it looks like it literally regurgitated what I wrote, Baz, or just like this, right? So it's just spitting out those words at the prompt. How did we get access to them? Well, it's actually pretty easy. So notice again that main is now being passed a special number, the number of words that were typed at the line, then a string, but not a string, an array of strings as represented here. So this represents the number of the words that were typed at the screen, at this command line. So let's see what happens. I print \n. Why am I iterating from I equals 0 to argc? Conceptually, what does that mean? Just iterate over all the arguments. Iterate from 0 to whatever the number of total words there were that were typed. And now this is familiar. %s means put a string here. What string do you want to put here? Well, if argv is said to be an array or a vector of words that were typed, turns out that syntactically, you can get at the first word by typing on your keyboard argv of 0. That's the very first word that was typed. argv1 is the second. argv2 is the third. argv3, 4, 5, 6, and so forth. Those are each of the individual words numbered from 0 on up that you typed at the prompt. So if I want to generalize this, I just say I, and this means get me the ith word that was typed at the prompt and print it out. So now I can go ahead and print this as follows. If I go back again, and I go ahead and run this, and I say, yes, indeed, enter. It does exactly that. But notice, too, it's also including not just the words I type after the program's name, but also the program's name itself. So this actually means you have the ability to see what your own name is, which is sometimes useful. But let's take this one step further. Not to make this too complex, but let's take this one step further. Let me go ahead and open up version 2 of this file. It looks a little scarier. Let me go down to my prompt and run argv of argv2. argv2. I'll zoom in, enter. Compiles OK. argv2, enter. Interesting. Hi. So what's this one doing differently? Obviously. So now it's doing not one word per line, but one character per line. So this suggests that programmatically, I must have the way not only to iterate over each of the words that the user types, but also over each of the just the characters that they typed. And that's because, too, just as argv itself is an array of strings, well, guess what a string is? It's an array of characters. So we can apply this exact same logic. Let me zoom in now on this version 2. And again, at the top here, I have this. And I simplified this a moment ago. This is the first training wheel that will eventually take off. When we keep saying string in C programs, technically, it's really something called char star. And the star is just a little confusing for now. So we hide it under the guise of something called string. But know for now that these are synonymous. It's just we're currently in the habit of calling those things strings. But we will get rid of that convention in a week or two. So now